Overexcited synchronous motor is used for power factor correction. A synchronous motor can develop synchronous torque only at synchronous speed. The maximum power developed in a synchronous motor will depend on the rotor excitation supply voltage and maximum value of coupling angle 90 degree. In a synchronous motor, the breakdown torque is directly proportional to applied voltage. A synchronous motor which works on a leading power factor and does not drive a mechanical load is called synchronous condenser. If the synchronous motor properly synchronized to the supply is running on no load and is having negligible loss, then the star current will be zero and the stator current will be zero. The coupling angle or load angle of synchronous motor is defined as the angle between the rotor and the stator poles of opposite polarity. The maximum torque which a synchronous motor will develop at rest for any angular position of the rotor at rated stator supply voltage and frequency is known as locked rotor torque. If the field winding of an unloaded silent pole synchronous motor is open circuited, the motor will stop. A synchronous machine with low value of short circuit ratio has lower stability limit. The maximum constant load torque under which a synchronous motor will pull into synchronism at rated rotor supply voltage and frequency is known as pull-in torque. The construction of a synchronous motor resembles an alternator. For power factor correction, synchronous motors operate at no load and greatly overexcited fields. Which of the following losses is not dissipated by the stator core surface in a synchronous motor? Windage losses. The size of a synchronous motor decreases with the increase in flux density. Which of the following losses in a synchronous motor does not vary with load? Windage losses. In a synchronous motor, the armature current has large value for both high and low excitation. The back EMF in the stator of a synchronous motor depends on rotor excitation. If the field of a synchronous motor is under-excited, the power factor will be lagging. In a synchronous motor, the damping winding is generally used to prevent hunting and provide the starting torque. In a synchronous motor, the back EMF generated in the armature at no load is approximately equal to the applied voltage, then the excitation is said to be 100%. In a 3-phase 4-pole 50 Hz synchronous motor, the frequency, pole number and load torque all are halved. The motor speed will be 1500 rpm. In a synchronous motor, V curves represent relation between armature current and field current. By which of the following methods the constant speed of a synchronous motor can be changed to a new fixed value? By changing the supply frequency. The torque angle in a synchronous motor is the angle between the rotating stator flux and rotor poles. A 3-phase synchronous motor is running clockwise if the direction of its field current is reversed. The motor continues to run in the same direction. The net armature voltage of a synchronous motor is equal to the vector difference of EH and V. In a synchronous motor, damper windings are provided on pole faces. In a 3-phase synchronous motor, the negative phase sequence exists when the motor is a column of mercury. A substance whose molecules consist of dissimilar atoms is called supplied with unbalanced voltage. due to which of the following reason a synchronous motor fails to pull into synchronism after applying DC field current, low field current. A rotary converter can also be run as a synchronous motor. In which of the following motors the stator and rotor fields rotate simultaneously? Synchronous motor. If the field circuit of an unloaded silent pole, synchronous motor gets suddenly open circuited, then the motor stops. A synchronous motor is running with normal excitation. When the load is increased, the armature current drawn by it increases because the R net resultant voltage in armature is increased. If in a synchronous motor driving a given mechanical load and driving current at a leading power factor from constant voltage supply, its field excitation is increased, its power factor will become less. Stability of a synchronous machine increases with increase in its excitation. If excitation of a synchronous motor running with a constant load is decreased from its normal value, ignoring effects of armature reaction, it leads to increase in both armature current and power factor angle. While starting a silent pole synchronous motor by induction motor action and connecting field discharge resistance across field starting and accelerating torque is produced by induction motor torque in field winding, induction motor torque in damper winding, eddy current and hysteresis torque in the pole phases, reheatance motor torque due to silence of the rotary. All of the above method. A synchronous motor installed at the receiving end substation operates with such an excitation that it takes power at lagging power factor. Now, if the applied voltage of the synchronous motor goes down, the power factor of the synchronous motor will improve. Which of the following motor will be used in electric clocks? AC synchronous motor. Power factor of a synchronous motor is unity when the armature current is minimum. Which of the following method is used to start a synchronous motor? Damper winding in conjunction with star delta starter. In a synchronous motor running with fixed excitation, when the load is increased 3 times, its torque angle becomes approximately thrice. A synchronous machine with large air gap has higher value of stability limit, a smaller value of inherent regulation, a higher synchronizing power which makes the machine less sensitive to load variations. All of the above. To limit the operating temperature, an electric machine should have current rating. When the voltage applied to a synchronous motor is increased, which of the following will reduce? None of the above. Slip rings are usually made of brass or steel. A synchronous motor has better power factor as compared to that of an equivalent induction motor. This is mainly because stator supply is not required to produce magnetic field. Asynchronous motors are not self-starting. A synchronizing power of a synchronous machine is inversely proportional to the synchronous reactance. When the stator windings are connected in such a fashion that the number of poles are made of, the speed of this rotor of a synchronous motor increases to 2 times the original value. When load on an over-excited or under-excited synchronous motor is increased, rate of change of its armature current as compared with that of power factor is less. Reunting in a synchronous motor takes place when load varies. The percentage slip in case of a synchronous motor is 0. When the field of a synchronous motor is under-excited, the power factor will be lagging. The oscillation in synchronous motor can be damped out by providing damper bars in the rotor phase pole faces. A synchronous motor can operate at lagging, leading, and unity power factor. If load or torque angle of a 4-pole synchronous motor is 6 degree electrical, its value in mechanical degree is 3. The minimum armature current of the synchronous motor corresponds to operation at unity power factor. A synchronous motor always runs at the synchronous speed. Under which of the following conditions hunting of synchronous motor is likely to occur? Periodic variation of load. A synchronous motor is running on a load with normal excitation. Now if the load on the motor is increased, power factor will decrease and armature current will increase. As the load is applied to a synchronous motor, the motor takes more armature current because the rotor, by shifting its phase backward, causes motor to take more current. The power developed by a synchronous motor will be maximum when the load angle is 90 degrees. A synchronous motor can be started by pony motor, DC compound motor providing damper winding, any of the above. A pony motor is basically a small induction motor. When the excitation of an unloaded silent pole synchronous motor suddenly gets disconnected, the motor stops. A synchronous motor can be used as a synchronous capacitor when it is overexcited. Mostly synchronous motors are of silent pole type machines. The working of a synchronous motor is similar to transmission of mechanical power by shaft. In a synchronous motor, the magnitude of stator back EMF and depends on DC excitation only. The back EMF of a synchronous motor depends on load angle. A synchronous motor can be made self-starting by providing none of the above. The shaft of synchronous motor is made of mild steel. The operating speed of a synchronous motor can be changed to a new fixed value by changing frequency. The maximum power developed in a synchronous motor occurs at a coupling angle of 90 degrees. In which of the following motor the stator and rotor magnetic field rotate at the same speed? Synchronous motor. A synchronous motor running with normal excitation adjusts to load increases essentially by increase in armature current. The efficiency of a properly designed synchronous motor will usually fall in the range 85 to 95%. The armature current of the synchronous motor has higher values for high excitation, only low excitation. When the rotor speed in a synchronous machine becomes more than the synchronous speed during hunting, the damper bar develops induction generator torque. While starting a synchronous motor by induction motor action, field winding is usually short-circuited by low resistance. Armature of a synchronous machine is of reducing number of slip rings on the rotor. Armature is associated with large power as compared to the field circuit of difficulty of providing high voltage insulation on the rotor. The power factor of a synchronous motor is better than that of induction motor because stator supply is relieved of responsibility of producing magnetic field. If one phase of a three-phase synchronous motor is short-circuited, motor will refuse to start. The maximum speed variation in a three-phase synchronous motor is 0. In a synchronous motor, the maximum power developed depends on all of the following except direction of rotation. The effect of increasing the load on a synchronous motor running with normal excitation is to increase armature current but decrease power factor. In a synchronous motor, the magnitude of a stator back EMF EB depends on DC. Hunting in a synchronous motor can not be done due to windage friction. A synchronous motor connected to infinite bus bars has at constant full load so percent excitation and unity power factor unchanging the excitation only. The armature curve will have leading power factor with overexcitation. A synchronous motor develops a maximum power when load angle is 90 degrees. The armature current of the synchronous motor has the large values for low and high excitation. Exciters of synchronous machines are DC shunt machines. The duration of certain short circuit tests on a synchronous motor is usually about 1 second. The maximum value of torque that a synchronous motor can develop without losing its synchronism is known as synchronizing torque. Usually following but in a self-starting synchronous motor is non-self-starting. The magnitude of a field flux in a three-phase synchronous motor remains constant at all loads. The ratio of starting torque to running torque in a synchronous motor is zero. The induced EMF in a synchronous motor working on leading power factor will be more than the supply voltage. Which of the following resistance can be measured by conducting insulation resistance test on a synchronous motor? Phase-to-phase winding resistance, stator winding to earth frame, rotor winding to earth to shaft. All of the above. The speed of a synchronous motor always remains constant when a three-phase synchronous generator is supplying a zero power factor lagging load. The armature field affects the main field in the following way: directly opposes it. If in a synchronous motor driving mechanical load and driving current at lagging power factor from constant voltage supply, its field excitation is increased, then its power factor become less. Change of DC excitation of a synchronous motor change power factor of power drawn by the motor. The mechanical displacement of the rotor with respect to the stator in polyphase multipolar synchronous motor running at full load is of the order of 5 degrees. An important advantage of a synchronous motor over one-round induction motor is that its power factor may be varied at will. The angle between the rotating stator flux and rotor poles is called torque angle. Slip rings in a synchronous motor carry direct current. A synchronous motor working at leading power factor can be used as phase advancer. The standard full load power factor ratings for synchronous motors are unity are 0.8 leading. The rotor copper losses in a synchronous motor are met by DC source. A synchronous motor will always stop when excitation winding gets disconnected. The speed regulation of a synchronous motor is always zero. In a synchronous motor, which losses varies with load copper loss. For weak curves for a synchronous motor, the graph is drawn between field current and armature current. An overexcited synchronous motor takes leading current. The synchronous motor is not inherently self-starting because the force required to accelerate the rotor to the synchronous speed in an instant is absent. When V is the applied voltage, then the breakdown torque of a synchronous motor varies at V. As V, a three-phase synchronous motor will have two slip rings. In case one phase of a three-phase synchronous motor is short-circuited, the motor will not start. Synchronous motors are generally not self-starting because the direction of instantaneous torque reverses after half cycle.